Hey guys, hi, welcome back. So in this video, we shall discuss the question of JEST, and all the questions will be from matrices. Okay. And we have already seen the theory of matrices. You can check the previous lectures if you're having any problem in the theory. So let's see the first question here. So here it is said for a n cross n matrix consisting of all one. So you're having a matrix which is n cross n, and all the elements of the matrix is one. So you will have to tell what will be the eigenvalues of this n cross n matrix. So here the first option is that all the eigenvalues is 1. So this is not correct because we have already seen in the properties, okay, that in eigenvalues and eigenvectors property, if we have seen, if you're having any matrix which is n cross n, right, and all the elements are 1, then one eigenvalue of this particular matrix will be its order, that is n, and all other eigenvalues will be what? 0, right? So if you see, the second option is also not correct. The third is also not correct. The correct option is option D. That is, one eigenvalue is n and all other eigenvalues are 0. All right. So this was a direct question from the theory. Now we will see the next question. So here given a matrix M is equals to 2, 1, 1, 2, which of the following represents cos pi m by 6? So matrix M is given to you. You will have to tell which matrix represents cos pi m by 6. Okay. So cos pi m by 6 you will have to find. So I'm taking here this pi m by 6, this factor to be a. Okay. This is equals to a. All right. Then you can write a will be equals to what? Pi by 6 into with the matrix M. Matrix M is what? 2, 1, 1 and 2, which can be written as what? It can be written as, if you multiply pi by 6, you will get it to be pi by 3. This is what? Pi by 6. This is pi by 6. This is pi by 3. Right? Now we will find the eigenvalues. Okay. So the eigenvalue equation is what? Now, eigenvalue of the equations. So eigenvalue equation is A minus lambda I. I is the identity matrix. It is equals to 0. So from here, I can write it as what? Pi by 3 minus lambda, right? And this also pi by 3 minus lambda. This will be pi by 6. This is also pi by 6. And it is equals to what? 0. All right. So if you see here, just doing the cross multiplication, you will get what? Pi by 3 minus lambda into with pi by 3 minus lambda. Okay. Minus pi by 6 whole square equals to 0. This is also what? Whole square. So it's a minus b whole square. So you can write it pi square by 9, okay, plus lambda square minus 2 pi by 3 lambda. And this is minus pi square by 36 equals to 0. So further keeping lambda square, arranging it, okay, lambda square is here minus 2 pi by 3 lambda. Again, if I take here plus, okay, 9 and 36 LCM will be what? 36, right? Here you will have what? 4 pi square minus what? Pi square. So this will give you what? This will give you 3 pi square by 36. That is what? Pi square by 12, right? So directly we can write lambda square minus 2 pi by 3 lambda plus, here you will have what? Pi square by 12 equals to 0. So now what we will do? We will solve this equation, okay, because this is a quadratic equation, right? So what you are having here, you are having here lambda square minus 2 pi by 3 lambda plus you are having pi square by 12 equals to 0. So use the quadratic equation formula, minus b. So minus of what? Minus 2 pi by 3. This is b, okay? You know the form, ax square plus bx plus c equals to 0. All right. So plus minus root over, you will have what? Minus 2 pi by 3 whole square, because the formula is minus b plus minus root over what? B square minus 4ac divided by 2a. Okay. This is minus 4. A is here 1 and c is here what? Pi square by 12. All right. Divided by 2a. So it is 2. So here you will get what? 2 pi by 3 plus minus root over. This will give you what? 4 pi square by 9, right? Minus this is what? 4 pi square by 12. This is divided by 2. So you can write 2 pi by 3 plus minus. So here if you see 12 and 9 LCM, we will have what? 36. So this will become 9 into with 4. So 4 4s are 16, right? Minus 12 3s are, so 12. This is pi square. Enter term divided by 2. So you will get 2 pi by 3 plus minus. This will give you what? 4 by 36 pi square. 4 how much? 9 here. Okay, I've cancelled. This is 2. So finally, what you will get here? Finally, here you can write lambda will be equals to, you will have to find lambda, okay? It is 2 pi by 3 plus minus. It's pi square by 9, so you will get pi by 3 divided by 2. So therefore, you can write here lambda is equals to what? 2 pi by 3 plus pi by 3 by 2, or it is 2 pi by 3 minus pi by 3 by 2. So if you see here, this will give you what? 3 pi by 3. So this is what? Pi by 2. Or when you will do this, it will give you what? 2 pi by 3. It is just what? Pi by 6, right? So pi by 6 is less. So I'm writing lambda 1 to be pi by 6 and lambda 2 to be equals to what? Pi by 2. So these are the two values of lambda 1 and lambda 2. Now we will do what? We will find the eigenvectors, right? So we will do this in the next step. Here if you see, we know the how you can find the eigenvectors. Ax is equals to what? Lambda x, right? So A, the matrix A was what? Pi by 3, pi by 6, pi by 6, pi by 3. Okay. X, I'm taking it to be what? A, B. Okay, lambda, this is for what? We are taking for lambda 1 equals to what? Pi by 6. So first we are doing lambda 1 is equals to what? Pi by 6. Okay, pi by 6. So here you will write this to be equals to what? So this is equals to lambda x, lambda is pi by 6 and this is x. So it is what? A, B. All right. Now you will just do the basic way how you can do, just multiply. You will get what? Pi by 3a plus pi by 6b. This is what? Pi by 6a plus pi by 6b. All right. This is what you will get. Yes or no? And it will be equals to what? Pi by 6a, pi by 6b. And from here you will get two equations. It is pi by 3a plus pi by 6b. It is equals to pi by 6a. Okay. And this will give you what? Pi by 6a plus pi by 6b. It is equals to pi by 6b. Right? So you can consider this to be equation 1. This is equation 2. So we will use equation 1 first. So if you see here, you will get pi by 3a minus pi by 6a. Taking this term to the left hand side plus pi by 6b, it is equals to 0. So LCM will be what? 6, right? This will give you 2 minus 1. So that is what? 1. So this will give you only what? When you will do so, we will just get it to be pi by 6a. And this is pi by 6b equals to 0. So pi by 6 taking common, you will get a plus b is equals to 0 and b is equals to what? Minus a. Now if you take, let b is equals to what? If you take a is equals to k, then b will be equals to what? Minus of a. So b is what? Minus k. Okay. Therefore you can write x is equals to what? A, b, and it is equals to what? K minus k. Clear? This you are getting x1. I'm taking this to be x1. Okay. Similarly, you can find the other one also. Now first we will normalize the eigenvectors. So the normalization condition is what? The normalization condition is bracket of this, it is equals to what? 1, right? So if you will write this Brian cat form, you can see the reverse, it will be k minus k. Okay, this is what? K minus k, it is equals to 1. So this will give you what? K square plus k square is equals to 1. K square minus 7c plus k square. So you will get finally k is equals to 1 by root 2. Okay, so this eigenvector is what? 1 by root 2 minus of 1 by root 2. Right? This what you will get? Similarly, you can find what? Using the other equation, you can find x2. Yes or no? AB. X2 equals to AB. So it will give you what? 1 by root 2, 1 by root 2. This time both will be what? Positive. And this is for lambda 2 is equals to what? Pi by 2. Clear? Clear? I am not showing the other one so that it will become very lengthy. Okay. Now for diagonalization, what we will do? We will consider a matrix. Okay. P is equals to what? X1, X2. All right. So 1 by root 2 you will take common because it is there 1 by root 2. X1, X2 will give you what? 1 minus 1, 1, 1. Right? So you will get what? 1 minus 1, 1, 1. All right. So similarly, from this you can write P inverse will be equals to what? P inverse will be equals to 1 by root 2. Just take rows into coulombs. So 1, 1 minus 1, 1. Okay. So the diagonalized matrix D is equals to what? P inverse A, P. Right? So when you will do this P inverse AP, I'm just doing and showing you. This is 1 by root 2. This is what? 1 minus 1, 1, 1. Okay. A is equals to what? It is pi by 3, pi by 6, pi by 6, pi by 3. And P is what? It is given here 1 by root 2. You will get what? 1 minus 1, 1, 1. So now you see 1 by root 2, 1 by root 2 will give you what? 1 by 2. Right. Now you will have to just multiply and see. You will just multiply this with this. So this will give you what? This will give you pi by 3 minus pi by 6. Similarly, if you do this, you will get what? Pi by 3 plus pi by 6. This into with this will give you what? Pi by 6 minus pi by 3. This into with the other one, what you will get? You will get here what you will get? Pi by 6 plus pi by 3. Right? And this is what? 1, 1 minus 1, 1. Okay. So D is equals to, just solve it and see. Pi by 3 minus pi by 6. LCM will be what? 6, right? 2 minus 1 is 1. So you will get what? Pi by 6. Again, this you will do. 6 is the LCM. So here it is 2. So they will get here what? Minus pi by 6, right? If you do this, you will get 6 is the LCM. So it will give you what? 3, right? So ultimately, here you will get what? 3 pi by 6. Here also you will get what? 3 pi by 6. This is what? 1 minus 1, 1, 1. So now again we'll multiply. Okay, so we are writing it in this side. So D is equals to what? 1 by 2, right? Again this and this. So you will get what? The first term will give you pi by 6 into with 1 minus a plus pi by 6 into with 1, it's pi by 6. Next you will do for this one, you will get here what? Pi by 6 minus pi by 6, right? Again this you do this side, you will get what? 3 pi by 6. Okay. Again this side you will get minus 3 pi by 6. Just you will have to do this with this. Okay. And this side what you will get? 3 pi by 6 plus 3 pi by 6. Done. So this term will become what? 0. So D is equals to what? 1 by 2. This will give you what? 2 pi by 6. Okay. This will give you what? 6 pi by 6. So that is pi. And here you will get 0. Here you will get 0. And finally D will be equals to what? This 1 by 2 if you multiply, it will give you what? Pi by 6, 0, 0, pi by 2. All right. So this is the diagonalization matrix. But what we know that P, D, P inverse, it is equals to what? P, P inverse, A, P, P inverse. Okay. Which can be further written as P, D, P inverse, it is equals to what? A. Because this is unitary. All right. You know, P, P inverse is equals to what? 1. Now we know we write cos A is equals to what? Cos A K is equals to cos pi m by 6. So this is PD, P inverse equals to A. Okay. So if I take A is equals to what? Cos A is equals to cos pi m by 6. This is what I will write. So cos pi m by 6, it is equals to what? P cos D, P inverse. This is how we can write. Okay. So finally you can write it as what? P is what? 1 by root 2. This was 1 minus 1, 1, 1. Cos D. Okay. So cos D means what? cos pi by 6, right? 0, 0, cos pi by 2. Because we know the matrix D was equals to what? You can just see here. Just a second. This is D. Pi by 6 I've put in cos. Okay, we have multiplied cos. So this is coming to be cos pi by 6, 0, 0, cos pi by 2. And here again you will get what? 1 by root 2 is there, okay? And here you will get 1 minus 1, 1, 1. So 1 by root 2, 1 by root 2 will give you what? 1. This is 1 minus 1, 1, 1. Cos pi by 6, its value is what? Root 3 by 2, 0, 0. Cos pi by 2 is what? 0. And here you will get what? 1 minus 1, 1, 1. All right. So finally, if you see here, if I take what? 1 by 2 common from here, so it's 1 by 4. So 1 minus 1, 1, 1. This will be root 3, 0, 0, 0. And it's 1, 1 minus 1, 1. Now we will just do the multiplication, okay? So this is 1 by 4. This matrix I'm keeping as it is. Just multiply this into with this. So it will give you here what? Root 3, right? This will give you here what? Minus of root 3. If you do this way, this will give you what? 0. This will give you what? 0. Similarly, if you do these two matrices, this will give you root 3. 1 into with 0 is 0. Again, this is what? Minus root 3. 1 into with 0 is 0. This is what? Minus root 3. This side 0. Again, this is minus what? Plus root 3, 0. So just do this. You will take root 3 common here. You will get what? 1 minus 1 minus 1, 1. All right. So your matrix cos pi m by 6, it is equals to what? Root 3 by 4, and it is 1 minus 1 minus 1, 1. Clear? So now let's check the option. It is root 3 by 4, 1 minus 1 minus 1, 1. Right? So the correct option is option B. It's a bit lengthy, but it's not that tough. Now, in the video, you might think that it's very lengthy, but when you will do, you can skip some steps as I have done each and every steps. Okay. So now let's see the next question, question number 3. Okay. Rho is equals to what? I. It is the identity matrix plus 1 by root 3 sigma x plus sigma y plus sigma z, where sigma are the Pauli matrices. Okay. I is the identity matrix. Then the trace of rho to the power 2017 is what? So rho is given to you. You will have to find the trace of rho to the power 2017. So first we will see what is the value of rho to the power 2017. We will find that matrix, right? So first you write rho is equals to what? Rho is equals to identity matrix plus 1 by root 3 sigma x plus sigma y plus sigma z. Okay, the entire term divided by 2. So rho square we will find. Okay, so this will give you 1 by 4, right? And here you will have what? I plus 1 by root 3 sigma x plus sigma y plus sigma z. And here you will have again I plus 1 by root 3 sigma x plus sigma y plus sigma z. Okay, so now we will do the basic multiplication. This into with this. It is the identity matrix I plus this term into with this. Okay, so you will get 1 by root 3 sigma x plus sigma y plus sigma z. Okay, plus again you will get 1 by root 3 sigma x plus sigma y plus sigma z, and plus when you will get this term into with this. So you will get what? 1 by 3 sigma x plus sigma y plus sigma z whole square, right? This is just the basic multiplication. So rho square is what? 1 by 4 I plus this is 2 by root 3. You can add these two terms. You will get sigma x plus sigma y plus sigma z plus 2 by, sorry, it's 1 by root 3 sigma x plus sigma y plus sigma z whole square. Okay, now you will do here what? You know the value of this. If you have read the Pauli matrices, you know the value of this is what? Sigma x plus sigma y plus sigma z is what? It's 3i, right? So finally, you are getting here what? This is 1 by 3, okay? 3 and 3 will get what? Cancel. So it will be just what? I. So you will get it to be 1 by 4. This will give you just I, na? The value is what? 3i. So 3 and 3 will get cancelled and you will have just I. So I plus I it is what? 2i plus 2 by root 3 sigma x plus sigma y plus sigma z. And finally, you will get rho square is equals to what? If you take 2 common, okay. If you take from here 2 common, if you take 2 outside, so you will have 1 by 2 because 2 will cancel 4 2 times, and you will have what? 1 plus 1 by root 3 sigma x plus sigma y plus sigma z. Okay, which is equals to what? This entire term, it is equals to rho or not? You can see. So you have seen what? Rho square is equals to rho. Okay, where n is what? N is any positive integer. Okay, you got rho 2017, it is equals to rho. That means it is I plus 1 by root 3 sigma x plus sigma y plus sigma z divided by 2. So first we will find this term. Okay, it's 1 by root 3. Okay, so here you are getting sigma x is equals to what? We will write the polymatrices. Okay, it is 0 1 1 0 plus here sigma y is what? 0 minus I 0, and sigma z is what? 1 0 0 minus 1. Okay, so keeping 1 by root 3 outside, 0 plus 0 plus 1, so it's 1 1 minus I plus 0 is 1 minus I. Again, this will give you 1 plus I, and here you will get minus 1. So this can be written as what? 1 by root 3 1 minus I by root 3 1 plus I by root 3 minus 1 by root 3. All right, now you will do what? You will just add with this the identity matrix 1 0 0 1. So when you will do so, what you will get? This will give you 1 plus 1 by root 3. Okay, again you will get what? 1 minus I by root 3. This will be 1 plus I by root 3. This will be 1 minus 1 by root 3, right? And you will have to multiply this entire term with what? 1 by 2. So which will give you rho 2017. It will be equals to what? 1 plus 1 by root 3, the entire term divided by 2. 1 plus I by root 3, the entire term divided by 2. 1 minus I by root 3, the entire term divided by 2. 1 minus 1 by root 3, the entire term divided by 2. Okay, so this is the matrix you are getting. Now you are asked to find the trace of rho 2017. Trace is what? Sum of diagonal elements. Okay, so the diagonal elements is what? These two. So take the sum 1 plus 1 by root 3. Okay, plus 1 minus 1 by root 3. 2 is the LCM. This 2 will get cancelled. 2 by 2 is equals to what? 1. So the trace is what? 1. So the correct option is option C. Clear? So this was not that complicated. The only thing is that you will have to do stepwise. Okay, now let's see the next question. So here it is said 2 of the eigenvalues of the matrix A equals to this are what? 1 and minus 1. So which one of the following is the third eigenvalue? You are given a matrix whose 2 eigenvalues are given. You will have to find the third eigenvalue. So first of all, what we know, trace is what? The sum of eigenvalues, right? We can write, we know sum of the eigenvalues, it is equals to what? Trace. And also we know what? Product of eigenvalues is what? Determinant. Product of eigenvalue, it is equals to determinant. Okay, so eigenvalues is what? 1 plus minus 1, okay, plus lambda 3 I'm taking. It is equals to what? Trace. Trace is the sum of the diagonal elements, so it will be what? A plus 2 plus 1, right? So this 2 will get cancelled. You will get lambda 3 is equals to what? A plus 3. That means you will get A is equals to what? Lambda 3 minus 3. Write it as equation 1. Okay. Next, what you will do? Product of the eigenvalues. It is what? Lambda 1 into with lambda 2 into with lambda 3. It is equals to the determinant. So determinant you can just calculate and see, okay, this into with this. So you will get what? A 2 minus 0 is 2. Again, if you put 3, so you will get what? Plus 3. This into with minus 3. 0 term will give you 0. So finally, this is what? 1. This is minus 1, right? So it is what? Minus lambda 3. This will give you what? 2a minus 9. Right? This what you will get. So lambda 3 is equals to what? It is 9 minus 2a. So from here, what you will get the value of a? You will get lambda 3, 9 minus lambda 3 divided by 2 is equals to a. Just a second. I'm writing it here. You will get a is equals to what? 9 minus lambda 3 by 2. Okay, here I am writing. Taking this to the left hand side, taking this to the right hand side. This is the value of a. So this is equation 2. Now from 1 and 2, when you will use equation 1 and 2, what you will get? Lambda 3 minus 3, it is equals to what? 9 minus lambda 3 by 2, right? Just do the cross multiplication. You will get 2 lambda 3 minus 6. It is equals to what? 9 minus lambda 3. Yes or no? Taking this lambda 3 to the left hand side, it's 2 lambda 3 plus lambda 3. It is equals to what? 9 plus 6. So this is what? 3 lambda 3 plus 15. So lambda equals to 15. So lambda 3 is equals to what? 15 by 3. That is equals to what? 5, right? So the third eigenvalue is 5. Clear? So you can just use this concept that sum of the eigenvalues is equals to trace and the product of the eigenvalues is equals to what? Determinant. Clear? So here what it says, let A be the Hermitian matrix and C and D be the unitary matrices. Which one of the following matrices is unitary? So A is Hermitian given to you. A is Hermitian. So we have already seen in the theory A is Hermitian. That means what? A dagger is equals to A. C and D are what? Unitary. Right. Unitary matrix means what? U dagger. It is equals to what? Identity matrix. U dagger represents what? U dagger represents the conjugate of U, then its transpose. Okay. So if C and D are unitary, then you can write what? C dagger is equals to C inverse and D dagger is equals to D inverse. Clear? First, let's check the first option. C inverse, okay, AC and C inverse AC dagger. Okay. So C inverse can be written as what? C dagger. This is AC. And here also C inverse can be written as C dagger, AC dagger. Clear? Now you can write C inverse AC as it is. Okay. And here you can write what? C dagger A. C dagger will be again C. Clear? So you will write C dagger A. Okay. C dagger A C. So this is what? I, right? So C dagger A C. So this will be giving you what? C dagger A square C. So it is not unitary because it is not equals to the identity matrix. Similarly, we will check the option B. So it is C dagger, sorry, C inverse DC, C inverse DC dagger. So C inverse is what? C dagger, DC will be same. This is what? C dagger, DC dagger. So this is C dagger DC as it is. And here you can write it what? You can write C dagger D, C dagger. Clear? So C dagger, D, C dagger, D, C dagger. This is the identity matrix. So you will write what? This will be only C, okay? So this is the identity matrix. So again, you will get C dagger, D, okay? So there is a dagger, okay, here. So D dagger, C. So this is again I. So C dagger, C. Again, it will be what? I, that is the identity matrix. So option B is what? It is a unitary matrix, okay? Because the matrix and its dagger is equals to what? Identity matrix. Similarly, I can check option C and D as we got the correct option B. So I'm not checking the next one. Now let's see the last question number 7. So here it is said a n cross n Hermitian matrix, okay, is not a multiple of the identity matrix. You are having n cross n Hermitian matrix A, and it is not a multiple of the identity matrix. So out of these 4 relations, which of the following is true? So we already know for a n cross n matrix, eigenvalues will be what? Lambda 1, lambda 2, up to lambda n, right? So trace of the matrix A is what? Sum of its eigenvalues, right? So it is lambda 1 plus lambda 2 plus up to lambda n. Clear? Similarly, if you take the trace of a square, because this is what it is required now, trace of a square. So it will be lambda 1 plus lambda 2 plus lambda n whole square. Clear? This is equation 1. Now you see, if you take the eigenvalue of what? We have already seen the properties, okay? So if the eigenvalue of a n cross n matrix is what? Lambda 1, lambda 2. So for a square, it will be what? It will be lambda 1 square, lambda 2 square, comma up to lambda n square. So now if I take what? Trace of a square, okay, multiplied by n, I'll get n into with what? Lambda 1 square plus lambda 2 square plus lambda n square, right? This is equation 2. So now when you add equations, the 1 and 2, you will see trace of a square, it is what? Lambda 1 plus lambda 2 up to lambda n square. And n into with trace of a square is having what? The sum of the eigenvalues into with what? N, right? So this is greater than this. So you can write n of what? Trace of a square. It is greater than what? Trace of a whole square, right? So the correct option is option C. Clear? If you're having any confusion, then you can go and just check the lectures. Thank you so much. Have a good day.